Hello, kind viewers and intrepid blockchain explorers. I'm Buck. I'm a software engineer at Tyrion, and I'm going to be introducing today a tool that we've been working on that we are open sourcing called the Bitcoin header node. This is a tool built on top of the Bitcoin library that lets you sync up a very lightweight node of just the headers of a Bitcoin block. And the purpose of this is that it enables you to very easily and trustlessly validate chain point proofs. And you can use this entirely on its own, running it and installing it through npm, running it on your system. We've also built it in directly to our Chainpoint CLI tool, which means that you can not only interact with the node, start it, stop it, get info about your node, and check on blocks, but also directly with using the verify command in the Chainpoint CLI, it will by default check against a local Bitcoin node to verify your Chainpoint proofs against the Merkle root that's in the Bitcoin header. So I'm going to be demonstrating the Chainpoint CLI today, so you can see how it works. If you've installed the CLI through npm, then you can just use the commands that I'll be showing directly like this. But I'm still in development, so we have to run it directly here. So if I just run this, it'll give you a bunch of help commands. It shows you what's available. So you can see here, bhn start to start a Bitcoin header node, execute to just fire off random RPC commands. A lot of them won't work if you don't have a full node, but the ones that will, like peer info, will be available. So I'm going to start up a node here real quick. So you can see what we're starting is a mainnet header node from height 500,000, so it's middle of the blockchain, and it's on mainnets, and I'm gonna, yeah, so that's it. If we start that up, it's going to run the start command. So this just tells you before you run anything that what the options are that you pass to it, where it will be storing it. You can see this by default, and actually, I'm going to start this also on in a default prefix, so you can see what it looks like from scratch. So this just sets a test. This sets a data directory where the database will be stored. All right, so you can actually see that come up here. And this is where it will be accessible if you don't want to use the CLI. All right, so you can see here it's starting the index from height 500,000. It's looking for peers, and it will start syncing up a node. You can see in a minute, once it's found peers, requests the header chain, and it will start adding blocks. Now, there we go. So we don't need to show too much of that, but because I already have one running, which you can see here, this one is running on testnet. Now, if I'm going to list, these are local Chainpoint proofs that I have here. So just to show you what this looks like for validating, all I have to do is run verify all. I need to tell it. Tell it to use the testnet network, because otherwise, so you can see here, now this is a hash ID node to identify the proof. If we run a this is the information for all of the anchors. So this is the Bitcoin anchors that we're running. And to verify that this, verified correctly, we can run a couple commands. So first, let's run, let's just get the block header for this height, BHN network testnet get. So we can see here we have the Merkle root, and for this one, this is in the proof, it tells us what the Merkle root we should be expecting to see is. So testing against that, the chain that we have running, that's this one here, we can see that they do indeed validate. Now, we can even go into an external block explorer to show that we have the same thing. So A1F25, A1F25. And that's it. That's all there is to it. Just to show, actually, if I, you can see here, before I added the network, see, this was testing against, this was trying to test against mainnet, but we don't have a mainnet node running, but that's okay because these are testnet nodes anyway. So this is going to fall back to a chainpoint node, and for the chainpoint node is going to relies on an external API like BlockCypher to check the Merkle root. So if we run it like this, it allows us to do this on our own against our own node. So yeah, I hope you enjoyed it. I hope people are able to get some use out of the Bitcoin header node and maybe come up with other use cases that we haven't thought about. And because this is all written in JavaScript with the Bitcoin library, you should be able to do a lot with it because it's all just plain old JavaScript. You could run it in the browser or run it in other environments as well. So yeah, we hope to see you guys on GitHub, and thanks for watching.